Hello and welcome to another video on capital budgeting. In this video we will discuss modified internal rate of return and payback period. One big problem that the internal rate of return has is that it assumes that all cash flows are reinvested at the same rate, at the IRR rate. This is widely optimistic. This means that after we get the money from cash flow 1, we have the same opportunities that we had when we first invested, meaning that we'll never run out of great projects in which we can invest our money. This is definitely not the case. So the MIRR is a different return, is a discount rate that causes the present value of a project's TV or terminal value to equal the present value of the cost of the project. So this is found by compounding the inflows of the WACC, thus solving the problem. Let's take a look at how this works. So for our project B, we take each one of these cash flows, and instead of taking them to present value, we take them to future value. The 60 becomes 66, the 10, 12, etc. The 80 are already in the future. And the terminal value of these inflows are 158. And we have 100 in terms of outflows. Now we calculate what is the rate that will give us that outcome. So from 100 to 158 in 3 years, and that rate is 16.5%. In Excel, as you may be imagining, the formula is MIRR, and then we include all the cash flows, and then we have a couple of rates, and in this case we need to put both of them, the WACC. So both of them are going to be at the 10% rate, and this gives us the 16.5% that we just saw on the slides. I can copy this here, paste it here, and we'll see that the returns are 16.89, 16.5, much closer instead of the big wide gap that we had before. But still, at 10% rate, we see that project front-loaded is better than project backloaded. So now let's talk a little bit about payback period. What is the payback period? Very simply is how many years before we get our money back. So again, for our project B, take this $100 here as the cumulative run on how much short we are to get to break even. So we start with 100 negative. On year 1 we get 10. That means that we're short 90, right? 100 minus 100 plus 10. Then the second year we get 60. That means that we're now short 30. And then between the year 2 and 3 is when we become positive. So the ratio we do here is the 30 that are left divided by the 80 that we're going to get on the third year gives them the fraction of years to year 2. So we know that we're going to get it after 2 years. We know for the negative number here. And the fraction, the 30 over the 80, is what gives us that fraction of years. Again, there's a big assumption that the money, these $80 come equally distributed in January, February, March, etc., and the money does not come all in December or in November. Well, strength is easy to calculate and understand. An indication of the project liquidity, but unfortunately this one ignores time value of money. There's no indication of what's an acceptable payback. Is 2 years good, or 3 years should be good, or 20 years? If we're talking about a nuclear plant, who cares? Ignores the cash flows that occur after the payback period as well. That's where most of the return may happen, or that's where the project turns bad. In reality, you should not care about when you get your money back. You should care about how much richer you're going to be. That's a relevant question. So there is an alternative method that is called the discounted payback. And this method is the similar approach, but instead of discounting or doing the cumulative with the dollars value, we do it with the discounted value. So this 909 is actually the present value of this 10. This $49 is basically $60 brought to time zero at 10%, and this 80 is this 60 is actually the $80 for 3 years at 10%. So once we lay up the numbers here, we get that the answer is 2 plus the fraction right now is not the 30 we had in the previous slide, but 41 divided by not the 80 but divided by the 60, which gives us 2.7 years. So we'll recover our investment in capital cost in 2.7 years. Okay, so here we're in Excel. I've already solved it. I just want to show you the formulas, how I arrived to this result. So first of all, I put the cash flows just like we had them, and then I'm making a sum here, minus 100, 160, 80. So this is nothing new. The cumulative cash flow, this is the same as we saw in the slide. I'm adding this one plus the payment, right? And you guys can pause this video at any point. And now I put a logic statement here, and all these formulas are the same, okay? So they all look the same. You can pause it and look at it. So what the formula does is that if this number is positive, means that, all right, we're recuperating the money. So that means that the number of years is going to be 2 plus what? Plus the fraction of 30 divided by 80. And if this number is not negative, the comma here, just give me a 0. So that's why you see the zeros here. Now, if we look at the discounted cash flows, the difference is that here I'm calculating the present value of these guys. This is the formula to calculate the present value of this $10 for 1 year at this 10% rate. The same is here. These are the $60, 2 years at the 10% rate, and the $80. Now I calculate the cumulative, just like you saw me doing it on the other side, the $90 plus the 49, the $41 plus the 60. And again, we know that the fraction here should be 41 over 60, and that's what we're doing, but we're putting a logic statement to make sure that this is positive. I hope this works for you guys.